Hello everyone, this is Jay. In this video, we'll take a look at the core page on the Nettletree Digital Twin website. First, let's go to the website. The website address is this nuclear-twins.tech.utexas.edu. You'll see a very cool homepage, right? So now, let's set that aside for a moment and click core on the top navigation bar. You'll be asked to enter a password. Yeah, I already logged in here. Probably did it. But anyway, if you'd like to access, please send me a brief message with your affiliation and reason for use. Then I will get it to you as soon as possible. Once you enter the password, you'll see this page. I've already written out the instructions here, but I'll walk you through them again in this video. First, you need to select the base core. There are two ways to do it. You can use one of the pre-saved cores, or you can upload your own core configuration. To use an existing network core, click the drop-down menu next to the base core and choose a core. Let's use this guy. Once selected, the core visualization should load successfully. Now, let's try designing our own core configuration. So let's reset this, and you're gonna download the template, and the template looks like this. So you'll see the columns for element numbers and radian burnups. You can fill these out manually, or you can download one of the existing cores, click apply, and download CSV, core CSV, and then you'll see this Excel sheet, and then you can edit it here. Okay. All right. So after your core is loaded, it's time to input the burner value and the click apply. So usually the annual burn up is about 500 to 800 megawatt hour, but let's type 500, 400, sorry. You'll see the right-hand side table now shows the new burner values in the last column, and the three buttons above the table have become active. We'll come back to these buttons later, but first, let's look at how to interact with the core visualization. When you hover your mouse over any fuel element in the visualization, you'll see its fuel number and uranium depletion info. Clicking a rod allows you to directly add these values, uh, and you can drag and drop the fuel rod to swap their positions. At the bottom of your core view, you'll also find the reactor pool, which shows spare fuel rods currently in storage in the pool. These rows are also editable, but note that the changes here do not affect the right-hand table or the MCMP calculation. You can also swap rows between the core and the pool if needed. Now let's talk about the three buttons above the table. Download core CSV. These export a CSV file listing each of your elements number and uranium depletion. Download MCMP input, and this gives you an info file compatible with MCMP 6.3, containing the detailed geometry and material specifications of lateral trigger, lateral trigger core. So let me open this. This file also includes comments at the top describing which base core you used and any fewer edits or swaps you made. You can see here. All right, now the simulate. This runs inference using a pre-trained neural network model that predicts K-effective, beta-effective, and big lambda based on the radium depletion of each fuel rod and the positions of the control rods. The model was trained on data from 20,000 MCMP runs using a tool called the PyLauncher. If you are curious about it, click the info card at the top of the screen. And there's a quick tutorial on the core page of Needle Trigger Digital Twin website. Thank you for watching.